Good afternoon, students. Welcome to the lecture of operational research. In the last lecture, we have started unit number 2, duality in LPP, where in detail we have seen how the concept of duality arises, and also we have seen with the help of one example that how for every LPP there exists one more associated LPP. Okay, therefore among the two LPPs, one is called as primal, another is called as the dual, and this is what the relation we have seen. Okay, what the changes we have observed here? There is a change in the objective function, maxima to minima. Okay, whatever are the costs involved in the primal objective function or the first LPP works as the right hand side constant in the second one. Same for the dual LPP as well. That is for the associated LPP. Whatever the right hand side constants of the first LPP will work as the cost, that is the coefficient of the variables in the objective function. And the changes, one more change we have observed is whatever is the coefficient transpose. Lastly, the less equal inequality will be observed as greater equal. These are some of the changes. Therefore, this is what we have defined primal dual problem. That is primal problem we have defined to be finding the variables x1 to xn, which maximizes zx. Suffix x we have used just to ensure that we are dealing with x variables, right? And which is subject to these constraints. All the constraints are of less equal form. Then the dual is obtained by four key points to remember. As the function we have stated here, as the objective function we have stated here is maxima type, therefore we have to minimize the objective function. We have to interchange the role of constant inequalities, and with all these we called as the dual variables b1 w1 b2 w2 up to bm wn, and these are the constants, right? Then later we have seen the matrix form of the given LPP as well, matrix form of the primal and the matrix form of the dual. While writing the matrix form of the dual problem, here instead of writing bw only, we have written b transpose w. I have explained already why there is necessity to write the transpose. Similarly, while writing the constraints also, we have written this to be a transpose w greater equal by c transpose. Okay. Now in today's lecture, what we are going to do, we will write the rules, general rules of converting a primal to the dual, and we will just go to solve some examples. Okay. Let me write the rules. General rules for converting. Actually, four key points we have discussed already. How to convert primal to dual. Converting
Yes, ma'am.
primal into its dual. Okay. As we have seen in the simplex algorithm or any other algorithms, first we have to maintain its standard form. Then we have to go for the general rules. Now here also, while converting a primal problem into its dual, we have to maintain a standard primal form. We have to maintain a standard primal form. And what is a standard primal form? Objective function maxima. All the constraints are a less equal type. Therefore, we will maintain the standard form first, and then we will write the rule of converting the primal into its dual. Okay. Therefore, what is my step number 1? Objective function is in the maximization. Therefore, here we will write first convert the objective function into maximization form. If not, if it is already in the maximization form, no need to convert. Therefore, we have to convert only if it is not in the maximization form. Okay. Now, say step number 2 is In step 2, we were going to convert all inequalities as less equal inequalities. Therefore, what we should do if any of the inequalities having greater equal symbol. Okay. What we have to do? We will multiply by negative sign, that is minus 1, so that the inequality greater equal inequality becomes the less equal. Therefore, here I will write if a constraint, if the constraint has inequality sign, greater equal, then multiply. Now here we were not ensuring that all the right hand side constants are non-negative. Therefore we are allowed with the right hand side constants to be negative as well, because multiplying by negative, the right hand side constants may become a negative. Multiply both sides by minus 1 and make the inequality sign less equal. Make the inequality sign less equal. Okay. Now third is what one should do if any of the constraint is of equal to sign. As I have told you already in the last lecture, if any of the equality sign, any of the inequality, any of the constraint is equality, then we can replace that equality constraint with the help of two inequality constraints going in opposite direction. One is of less equal, another is of greater equal. We will keep less equal inequality as it is. Only we will convert the greater equal inequality by to less equal by multiplying with a minus 1. Therefore, here we will mention this. What we will mention, if a constraint has, an equality sign, comma, then it is replaced by two constraints going in opposite direction. Going in opposite direction is a reverse, no? One is less equal, another is greater equal. Going in opposite direction. And the second inequality which inequality second means, here we will consider second inequality with greater equal sign can be further multiplied by minus. Is the point clear? Now one more point here we want to cover is unrestricted variable. Actually, whenever an LPP is given, all the variables are given to be non-negative. But suppose if any one of the variable is not restricted, that is not given to be non-negative, then what we should do? While taking the example, we will discuss in detail. Therefore, here every unrestricted variable is replaced by difference of two non-negative variables. Okay, here I will mention an example. If x1 is unrestricted, means it is not given that x1 is non-negative, then what we were going to do, we will replace this x1 by x1 dash minus x1 double dash, where x1 dash and x1 double dash are which are involved in the LPP instead of what in which first point, or one can say there are two standard ones even. First is all the constraints, have less equal sign and objective function is maximization type. Okay, this is first. Or second type is all the constraints. Actually, we were not going to consider the second one. We will follow the first one. All the constraints have greater equal sign and objective function is minimization. Okay, generally we were following the first one because the rules also we have written in order to get the inequality constraint to be less equal form and objective function is the maximization. Okay, then what is the last step? Step number 6 tells us yes, dual problem is obtained by. Dual is obtained by. Dual is obtained by. First, transposing the rows and columns, transposing the coefficient matrix, I like. Transposing the coefficient matrix. Okay. Second one, interchanging right hand side constants with coefficients of objective. Let me write it on the next page. Interchanging the right hand side constants with coefficients of objective function. Can anyone tell me the third one?
Reverting the signs of inequality.
Yes, changing the inequalities. Changing the inequalities from less equal to greater equal sign. What remains? What remains? We have transposed the coefficient matrix. We have interchanged the right hand side constant with coefficients of objective function. We have changed the inequalities. Last one remains regarding objective function, right? Therefore, we have to minimize. Minimizing objective function. Correct, na? Is this clear up to the rules? To all the
Yes, ma'am.
students. Okay. Let us go for examples. The first example I'll consider is maximize z is equal to 2x1 plus 3x2 plus 4x3 subject to. Let me write the constraints. 2x1 plus x2 less than or equals to 1, x2 or x1 plus 5x2 minus x3 less than or equals to 2, and last one I will write as some 7x1 plus x2 plus x3 equal to 3, and all the variables x1, x2, x3 are greater equal by 0. Therefore, the problem is of 3 variables and 3 constraints. But if we look at the constraints, whether this is a standard primal form, okay, what is my standard
No, ma'am.
primal form? Objective function maxima, all the constraints are of less equal set. But here, no doubt objective function is maxima, but out of 3 constraints, 2 constraints are less equal type, but this third one is of equality. Then what one should do? We have to convert this equality constraint into 2 inequalities with less equal sign. Correct now? So what we have to write? The inequality, the constraint I will write in starting. The constraint 7x1 plus x2 plus x3 equal to 3 can be written as. Can be written. How can I write this? This is actually 7x1 plus x2 plus x3. First inequality I will write, it is less equal by 3. Then 7x1 plus x2 plus x3, and the second one is my inequality is greater equal by 3. Okay, but we want both the inequalities to be less equal form. Therefore, what should I do? I multiply the second inequality by minus 1, so that it becomes minus 7x1 minus x2 minus x3 less equal by minus 3. Okay, now our given problem is in the standard primal form. Therefore, here I will write thus standard primal form is. What is my standard primal form? Maximize z 2, 3, 4. Zx we have 2x1 plus 3x2 plus 4x3 subject to the constraint. What is my first constraint? 2x1 plus x2 less than or equals to 1. What is my second? 1, 5, 1, 5 minus 1. X1 plus 5x2 minus x3. Now we will write these two remaining constraints. Here it is 7x1 plus x2 plus x3 less than or equals to 3 minus 7x1 minus x2 minus x3 less than or equals to minus 3, and x1, x2, x3 greater equal by 0. Therefore, whatever this we have written is our standard primal form. What the standard primal form tells us? Objective function is maxima type and all the constraints are of less equal sign. Now we will go for writing its dual. The dual for is given by. How can I write the given dual form? No doubt this is minima ZW we will write, because we are going to use new variables called as the dual variables. Let me write W variables. What will be my objective function? Which role we were interchanging? Coefficients of objective function with right hand side constant. Correct na? How many
Yes,
dual
ma'am.
variables are required?
4.
1, 2, 3, 4. Good. Therefore, the objective function is it 1W1, 2W2, 3W3 and minus 3W4. 3W3 minus 3W4. Is it okay? Subject to the constraints. Now how to write the constraints? Upgrade the constraints. We have to transpose this matrix, no? Whatever is this coefficient matrix, we have to transpose. Means this first column should be written as a first row. But let us try to write the first row 2W1 plus W2 plus 7W3 minus 7W4. Is it okay to everyone? 2W1 plus W2 plus 7W3 minus 7W4. Is it okay? 217 minus 7 is the first column in the coefficient matrix of a primal problem that we are writing as a first row in the dual. Okay? This less equal inequality now becomes greater equal. And what is the right hand side constant?
It's 2.
Yeah, it's 2. The first coefficient. 2. Now let me repeat the same thing. Let me write the second column as the second row. What is my second column in this coefficient matrix? Is it 1, 5, 1, minus 1? Right? Therefore, this is W1 plus 5W2 plus W3 minus W4 is a greater equal 1. Yes?
It's 3.
It's 3. Now let me write my last constraint. Now here as it is no x3 variable means this value is 0. 0 minus 1 plus 1 minus 1. Correct now? Therefore here our variable starts with minus W2 plus W3 minus W4 and is greater equal by 4. Okay, and what about this? W1, W2, W3, W4 greater equal by 0.
Yes, ma'am.
This is the dual. And suppose if someone wants to make it more simplified, then what one can do is if you look at these pairs, if I take 3 common here, this is W3 minus W4. If I take 7 common here, W3 minus W4. Therefore, we can replace the W3 minus W4 as a new variable. Here, let me show you. Now, this is not mandatory to do. Let us put what I will write W3 dash I will call. W3 dash as W3 minus W4. What are the changes? Objective function is minimize ZW is equal to W1 plus 2W2 plus 3W3 dash. Is that okay? 3 I have taken common. It remains with W3 minus W4. Now let me write about the constraints. What will be the constraint? 2W1 plus W2. 7 we were going to take common. V remains with W3 minus W4. Therefore, this is 7W3 dash greater equal by 2. Next, from these two, I will replace as W1 5W2 plus W3 dash greater equal by 3. And lastly, this is minus W2 plus W3 dash and this is greater equal by 4. Now, what are the new variables? W1, W2 are the old variables. Both are non-zero. But can we write W3 dash as non-zero? Greater equal by 0, non-negative. W3 dash we have written as a difference of these two numbers. Therefore, the value of W3 dash depends upon W3 and W4. If W3 is greater equal by W4, that is W3 minus W4 is greater equal by 0, then we will get W3 dash non-negative, or what will happen? If W3 is less equal by W4, that is W3 minus W4 is less equal by 0. In this case, we will get W3 dash is less equal by 0. Therefore, here the value of W3 dash is not fixed, whether it is non-negative or non-positive. It totally depends upon the relation between these two variables. Therefore, here one can say that this W3 is unrestricted. There is no restriction on this, correct? No? Is everyone getting me? If you write up to
Yes.
this dual form, then also it is okay. Actually, this is one of the next theorems, so that I have explained here itself. Okay, let me take one more example of involving. Therefore, here one more point to notice is if the third constant is equality, we have obtained third variable is unrestricted. If the third constraint is equality, we have obtained third dual variable as unrestricted variable. This is your one theorem. If pth constant is equality, then the pth dual variable is unrestricted in set. Okay. Let me go for one more example. Example number 2. Minimize zx is equal to x1 plus x2 subject to x1 plus x2 less than or equals to 2, 2x1 plus x2 less than or equals to 4, x1 non-negative and x2 is unrestricted. x2 is unrestricted. Okay, whenever a variable is unrestricted, what algorithm tells us? Every unrestricted variable is replaced by the difference of two non-negative variables, right? So here we will follow this rule, this step. This is what we will check whether the primal form is in the standard form or not. Is it in the standard form? Whether the given primal is in the standard form?
No, ma'am.
No, ma'am.
No. Therefore, here we have to change the objective function first. Change the objective function to maximization. Correct? How we are doing this? This is maximize.
Yes,
May I
yes.
write? Huh? Zx dash minus x1
Yes, ma'am.
minus x2. What is zx dash? This is minus zx, no? Yes, no? In LPP we have seen this, how to change
Yes, ma'am.
minima to maxima. So here maxima is minus zx actually, but that minus zx we have written zx dash. Maxima is zx dash is minus x1 minus x2. What about inequalities? Both the inequalities are in the less equal form, therefore no need to change. Only we have to take care of the unrestricted variable. Therefore, what we will do? We will replace that unrestricted variable. Okay, replace the unrestricted variable x2 as. How I am going to replace? Let me replace this x2 by x2 dash minus x2 double dash, where both these variables used x2 dash and x2 double dash are non-negative. Okay, now what we will do? We will make all these changes and we will write the standard primal form. The standard primal form is what will be my standard primal form? Maximize zx dash is equal to minus x1. This x2 we will replace by x2 dash minus x2 double dash. Is it okay?
Yes, ma'am.
Hmm. What for constraints? In constraints also we have the variable x2. Therefore we will also replace this. This x2 we will replace. x1 plus x2 less equal by 2. x1 plus x2 is there. This I will replace by x2 dash, x2 double dash less than or equals to 1. Na? What is the second constant? 2x1 plus x2 less equal by 4. 2x1 as it is plus x2, x2 dash minus x2 double dash less equal by 4. Now and which are the variables used? x1, x2 dash, x2 double dash, both all the three are non-negative. Okay, is it the standard form or not? Objective function
Yes, ma'am.
maxima, all the constraint less equal and the variables are non-negative. Now we will write its dual. The dual form is or can be written as whatever you want to do. Maxima to minima we have to go, of course. So this is minima ZW. But ZW dash also one can write because here we have the dashes. Yes. How many dual variables are required?
2.
2. 2W1 plus 4W2. Correct na? Right hand side constants. 2W1 plus 4W2. Subject to the constraints. What about the constraints now? Again, we have to write transpose of this matrix. First column should be written as first row. What is the first column? This is 1, 2. What is my first constraint? W1 plus 2W2. Less equal, we have to convert to greater equal. Greater equal by, yes, what is the right hand side value?
-1.
Yes, it is minus. Next, second row, second column is 1, 1. We will write this as first, second row. W1 plus W2 greater equal by, yes,
-1.
minus 1. Now the last column is minus 1, minus 1. What is my row? Minus W1 minus W2 greater equal by x2
+1.
dash. This is plus 1. Yes. Okay. And what for W1, W2? Surely non-negative. Okay. Now what we will observe here is, we observe that last two constraints. If I multiply this constraint, second constraint by negative sign, what it will be? Is it W1 plus W2 less equal by minus 1?
Yes, ma'am.
And the same is the second inequality with opposite sign. Therefore, combining both, may I write this as an equality constraint?
Yes, ma'am.
But here one can write combining these two, is it W1 plus W2 equal to minus 1? Combine. Or you can write it again. Okay, therefore this is the dual. Therefore here, if the second variable is unrestricted, if the second original variable is unrestricted, the second constant we get equality. Correct na? This is my first constraint, correct? And combining these two, we have obtained this to be second constraint. Okay? Now that we are going to observe these as the theorems. Okay? Now to write this again, the dual form again. Minimize ZW dash, first equality, second, first constraint, second constraint. Okay? Any doubt about solving the examples now? Whatever is the kind of problem given to you, so you first try to convert it into a standard primal form, that is objective function maxima, all the constraints in less equal form and all the variables are non-negative. Therefore, here we have to take a special care of the unrestricted variable. Special care of unrestricted variable. I can give you some examples for homework as well. If possible, you can solve along with me. Because in operation research paper, everything depends upon practice, problem solving. It's not a theoretical paper. Okay, here it is given that x3 is unrestricted. Also, objective function in minima, if we have to convert to maxima. The second equal constant is equality. You have to replace with two inequalities. Correct now? Let me write one more example for homework. Okay. Likewise, you can solve, you can construct the examples on your own and you just find its dual. Now we will go for some important theorems. Let me come to the next page because here onwards we will take all the important theorems on duality. The first theorem under this heading we are going to observe is the dual of dual is a primal problem. First theorem we will see is the dual of a given primal is the primal. Try to understand the statement. Dual of dual means what? Whatever is the primal given to us, we are twice finding the dual. Okay. And after finding twice the dual, whatever the second dual we will obtain is nothing but the original primal problem. You can check it orally also. No? Suppose in the first standard form I have maxima. If I convert it to dual, it will be minima. Again, if I convert it to if I want to convert it to maxima, it will be dual. It will be maxima. Okay. First constant type gives me less equal. Dual gives us greater equal. Again, if I find its dual, it will be less equal. Okay. Why you may get confused along with this? Because we have seen only this form. Let me tell you. There are two standard forms we have mentioned. All constant less equal sign, objective function maxima. All constant greater equal, objective function minima is the second form. If suppose in some of the example all the constants are given in greater equal sign only, then instead of multiplying all those constants by -1 and then converting to the first standard form, what you do is you keep this with a second form, that is constant greater equal objective function minima, and do the rest process. What will be the objective function then? If I consider this as a standard form, if I consider this as a standard form, that is objective function minima, then its dual will contain maxima. Constant will be less equal,
Yes, ma'am.
transposing the coefficient matrix, interchanging the role of first and right hand side constant. Rest gives me the same value. Let us try to prove this. Now we will give the proof by using the first standard primal form. Okay, dual of the dual. Therefore, what we will do, we will start initially with the standard primal form, maxima objective function less equal constant. Then twice we will find its dual also. Okay. What will I do? Primal I will write. Now, what is the primal I am considering? Standard one. Maxima is zx is equal to general we have to write c1 x1, t2 x2, dot up to en xn. Subject to a11 x1, a12 x2, a1n xn less than or equals to b1. Let me write one more. 21 x1, 22 x2, 2n xn less than or equals to b2. Continue. What is my last one? Nth constraint. am1 x1, am2 x2, amn xn less than or equals to bm, and all the variables x1 to xn are non-negative. We have started with the standard primal form. Now let us write its dual. What is the dual? Objective function is minima. W variables I will use. What is the objective function?
Is
B1W1.
Yes, good. This is B1W1
B1W1 plus B2W2 up
so
to
on
so
up
on
to BM.
BMWM.
Good. Okay, what about the constraints? This first column we have to write as first row.
is A11W1 plus
Hmm,
A21W2 plus up to so on AM1WN
good. Greater
less
equal
than
by
equal to greater equal by C1.
C1. Tell me the second one. Is it A12W1, A22W2 up to AM2 WM greater equal by C2, and let me continue with the last. This is A1M WM A2M W2 WM greater equal by Cn. See, one thing to note is the role of number of variables and number of constraints gets interchanged. Correct now? In this problem we have n variables. N variables and m constraint. Correct? But in the dual, what it becomes? We have m variables and n constraints. Correct? No?
Ma'am, the last constraint is A1 and W1 plus
Yeah, it's A1 and 2n.
A21.
Sorry. Let me write it. 1 and 2n and up to mn. Na? A1
Yes,
and
ma'am.
1 and 2n up to the last mn. Okay, I think it's okay now. And all the variables w1, w2 up to wm are non. Correct na? Now we have to find one more dual. We have to find one more dual. But before converting this to a dual, what we know? We have to convert it to a standard primal form. Now what is the standard primal form we have followed? Objective function maxima, constraint, less equal. Or you can write the dual at this stage as it is. How can you write the dual at this stage as it is?
Converting the objective function into maxima
Yes,
and
maxima
corresponding changes.
changes. Shall I write directly or shall I convert to a first standard and then dual?
Write directly.
Otherwise, it may create a confusion. Okay, what I'll do, I'll show you with this. I'll convert this to first standard primal form. That is objective function maxima constant less equal. To find dual of, I'll give this numbering to this system of equations. This I'll call 1. The system of equations I'll call 2. To find the dual of 2, we convert it to standard primal form. Okay, what is standard again? This minima I have to change to maxima. So this is maximize ZW dash minus B1 minus B2 minus B2W2 minus BMWM subject to. What I have to do in order to convert the greater equal constant to less equal
Multiply
multiplying by
by
minus
minus
1.
one.
Hmm. 1, 1, 2, 1 up to n. Now it is less equal by minus c1. Correct, no? Next, 1, 2, 2, 2, m2. Let me continue this, and last is 1 and 2 and m. Less equal by minus c, and no doubt w1, w2, 2wm are non-negative. Now this is in our standard primal form. Now we'll find the dual of this system of equation number 3. Okay, now we will find dual of 3. Correct now? Now what's the dual of this 3? Minima, new variables, and let me use some v variables. Minima zv dash minus c1 minus c2. Correct now? If you are having a problem at any stage, you can know. First, shall I give the heading now? Dual of dual. Correct now?
Yes, ma'am.
Now what we will do? This is minimize zv variables I will use. What is the objective function now? Minus c1 minus c2 up to minus c1 v1 minus c2 v2. No?
Yes, ma'am.
Subject to. Now again the first column 1 1 1 2 1 n becomes a first column. Everything is with negative sign. A11 W sorry V1 no? New variables. A11 V1 minus A12 V2 dot up to A1n Vn, and is greater equal by less equal no?
Minus
Greater
v1.
equal by minus 2 1. Continue up to minus am1 v1 minus am2 v2 dot minus amn vn is greater equal by minus vm, and the variables v1 v2 up to vn are non-negative. Okay, now look at this problem. Whatever is the dual of dual we have formed, this is minima zv of negative. Therefore let me write it as a maxima zv dash, and let me absorb the negative as well. The above system can be written as. How can I write? Now I will write maxima zv dash I will write. Correct na? Maxima zv dash. Is it C1 V1, C2 V2 up to Cn Vn subject to. And what is zv dash? Is it minus zv? And what are my
Yes, ma'am.
constraints? The constraint should be multiplied by the negative symbols, negative signs, so that all this greater equal becomes less, absorbing the negative. A11 V1, A12 V2 up to A1n Vn less than or equals to B1. A21 V1, A22 V2, A2n Vn less than or equals to B2. Similarly, AM1 V1, AM2 V2 till AMN Vn less than or equals to Vn, and all V1 V2 to Vn are not call this as system of equation number 4. Now you have to just look at system 1 and system 4. Is it very similar to the first form we have? Only there is a change of variable, but variables doesn't matter because it is actually finding the values of the variables, right? Okay, shall I write which is the system identical to 1? Okay, hence dual of dual is prime. Dual of dual is prime. Okay, if you have some 5 minutes more, then I can show you this with the help of uh, or a shortcut I can say with the help of using summations. The same proof. Okay, instead of writing all the equations deliberately separately, we will use a summation form. First, maximize zx. Let me write as a prime. Maximize zx is, yes, is it summation tjxj j from 1 to n subject to summation j from 1 to n aij xj less equal by bi. I takes the values 1 to m and j takes the values no doubt 1 to n. Is it the primal form? Let me show you
Yes,
the
ma'am.
first primal form. Okay, C1, Cjxj means C1x1, C2 up to Cnxn and this. Now here as the sum is running over J, sum is running over J, what kind of statement it is? A1, AI1, x1, AI2, x2 and so on. And for every value of I, we will get one equation each. Okay, now what will be its dual? Let me call this as 1. Dual. We are not writing a matrix form, okay? This is not a matrix form. This is just by using the summation. For may I write this as minimize ZW is equals to summation I from 1 to M now. And this is BI, WI subject to. Same variables we were using, only the same coefficients we were using, only variables are changed. Now the summation must run for I 1 to M and is greater equal by Cj, and this is for every j equals to 1 to n. Just look, as the summation is over I, therefore this statement is A1jw1, A2jw2, etc. And for every j gives you one statement. But this is my dual. Is it okay?
Yes, ma'am.
Now we will convert this to a standard. Okay, let me call system 2. Let us write system 2 in standard primal form. Why I am writing in this standard? Because I want to find its dual. What is the standard primal form now we have taken? Maxima, objective function maxima, constraints less equal. So what should be a change accordingly I should do? This is maximize ZW dash, correct na? ZW dash, yes. Is it summation I from 1 to n minus bi, I'll keep it in a bracket. This is minus summation minus BIW. Now we have to change this with a negative coefficient. Let me put it in a bracket. And what is ZW dash? No doubt minus ZW. Okay. Now what is the effect on the constraint? We want to change this greater equal constraint to less equal. Therefore, let us multiply by negative. Summation I equals to 1 to M AIJWI less equal by minus CJ. J from 1 to N. Is it okay? Now this is the standard. Now we will find its dual. Now we will find dual. What that dual will be now? Dual of dual. What is the dual of dual now? Again, this is minima, some ZV I will use. Okay. Now this is minus Cj we have to collect. Correct, na? So this is summation over J, Tj, Xj. J from 1 to n subject to. What is the dual again? Again, we have to change this parameter. J from 1 to n, Aij, Vj greater equal by minus Vn. I taking the values 1 to m. Okay. Now, if I take the values 1 to m, now let us rewrite it. Now we will try to write in a standard again. So this is maxima zv dash minus cjxj summation j. Oh, sorry, not xj. Here it is vj, no? I'm not allowed to use xj. Vj I have taken. Cj, vj. And what for this? Minus I have collected, I think, yes. Minus I have forgotten. Now, this constant, let us absorb the negative. Summation j equals to 1 to n aij vj is less equal by vi I equals to 1 to, yeah, let me call this as system number 1 to I have used, I think. 3. Now this is nothing, this system 3 is identical with, which is the system identical with 1. Hence the proof. Yes, any difficulty in the proof of the theorem? I think you are having one more lecture. Okay, any doubt, any difficulty in the proof of this theorem? Two different methods I have shown you to prove this result. Dual of dual is prime. Any difficulty?
No, ma'am.
Let us stop here then. And we will continue the next theorems in the next lecture. Now, please be with me for the further lectures as well, because from now 2-3 days we have to complete the theorems only depending on duality. Okay. Thank you for being with me for today's lecture. Thank you.